Hello everyone, this is SK.Masthan Vali, Department of Mechanical Engineering, Jansen's Institute of Technology. Today I am here with a case study on cathode ray oscilloscope, which is an electronic device. Now let's have a small intro on cathode ray oscilloscope. The cathode ray oscilloscope is an electronic test instrument. It is used to obtain waveforms when the different input signals are given. In earlier days, it is called as an oscillograph. The oscilloscope observes the changes in the electronic signals over time. Thus, the voltage and time describes a shape and it continuously graphed beside a scale. By seeing the waveform, we can analyze some properties like amplitude, frequency, rise time, distortion, time interval, and etc. Let's have a look on block diagram of CRO. It consists input and output signals, vertical and horizontal amplifiers, vertical and horizontal deflection plates, delay line, electron gun, luminous spot, phosphorus screen, trigger circuit, time-based generator, and few other parts. Let's get in detail by the studying of the block diagram. The following block diagram shows the general purpose CRO contraction. The CRO recruits the cathode ray tube and acts as a heat of the oscilloscope. In an oscilloscope, the CRT produces the electron beam which is accelerated to a high velocity and brings to the focal point on a fluorescent screen. Thus, the screen produces a visible spot where the electron beam strikes with it. By detecting the beam above the screen in reply to the electrical signal, the electrons can act as an electrical pencil of light which produces a light where it strikes. To complete this task, we need various electrical signals and voltages. This provides the power supply circuit of the oscilloscope. Here we will use high voltage and low voltage. The low voltage is used for the heater of the electron gun to generate the electron beam. A high voltage is required for the cathode ray tube to speed up the beam. The normal voltage supply is necessary for other control units of the oscilloscope. The horizontal and vertical plates are placed between the electron gun and the screen. Thus, it can detect the beam according to the input signals. Just before detecting the electron beam on the screen in a horizontal direction, which is in x-axis, a constant time-dependent rate, a time-based generator is given by the oscillator. The signals are passed from the vertical deflection plate to the vertical amplifier. Thus, it can amplify the signals to a level that will be provided the deflection of the electron beam. If the electron beam is detected in x-axis and y-axis, a trigger circuit is given for synchronizing these two types of detections. Hence, the horizontal deflection starts at the same point as input signal. Working principle of CRO. The CRO working principle depends on the electron ray moment because of the electrostatic force. Once an electron ray hits a phosphorus phase, then it makes a bright spot on it. A CRO applies the electrostatic energy on the electron ray from two vertical ways. The spot on the phosphorus monitor turns due to the effect of these two electrostatic forces, which are mutually perpendicular. It moves to make the necessary waveform of the input signal. Let's have a look on applications of CRO. The CROs are used in huge applications like radio stations for observing the transmitting and receiving the properties of the signals. The CRO is used to measure the voltage, current, frequency, inductance, admittance, resistance, and power factor. This device is also used to check the AM and FM circuit characteristics. This device is used to monitor the signal properties as well as characteristics and also controls the analog signals. The shape of voltage and current waveform can be observed by CRO, which helps to make the necessary decision in a radio station or communication station. It is used in laboratories for the purpose of research. Once researchers design a new circuit, then they use CRO to verify the waveforms of voltage and current of every element of the circuit. The CRO is used through the resonance circuit to view the shape of the signal, bandwidth, etc. It is used for comparing phase and frequency. It is used in televisions, radar, and analysis of engine pressure. It's also used to check the reactions of nerves and heartbeat. In the hysteresis loop, it is used to find BH curves. Using CRO, transistor curves can be traced. I hope after seeing this video you all guys have a basic idea about CRO and its applications. Thank you.